Okay, in section 7.4, we're going to be dealing with linear inequalities in two variables and their solutions. Okay, we'll do some similar work to what we did with linear equations in two variables. Okay, and ultimately, what it boils down to is if we have a line here, notice it's written in standard form in this case. It says if we can change the equal sign to one of the inequality signs, we obtain a linear inequality in two variables. So, for instance, instead of having a linear equation, you'll notice that these are very similar, except for the equal sign is now a less than sign in this case, and a greater than or equal to sign in this case. We call these linear inequalities in two variables. Okay. Now, ultimately, a solution to an inequality in two variables, x and y, is an ordered pair of real numbers such that when x is substituted for x, y is substituted for y, the inequality gives us a true statement. Okay. Now, keep in mind that unlike an equation, if we were to find a system, if we were to find a x and y that made this sentence true, like for instance, if that were an equal sign, I could put in 1 and 1, and that would make that true. Okay, and we know that there's going to be an infinite amount of solutions to the equation because when we graph that, it's going to be a line. Every point that's on that line is going to make that sentence true. Now, when we have an inequality, okay, 1 plus 1 would give us something that equals 2, not less than 2. So 1 plus 1, or 1, 1, is not a solution to this. Okay, however, if I did the point 0, 0, that would be a solution to this because that would make this sentence true. And ultimately what we're going to wind up with is the line that we generally would graph, okay, and either one side or the other of it shaded. So the graphs that we're going to draw are going to involve some shading, and we'll see that here in a minute. Okay. So that said, the graph of an inequality in two variables is the set of all points whose coordinates satisfy the inequality. Okay. Now we have a nice set of notes here that we're going to use to follow carefully and be able to graph a linear inequality. And the first one is we're going to replace the inequality symbol with an equal sign and graph the corresponding linear equation. We're going to draw the line solid if it is a less than or equal to or a greater than or equal to, and we're going to draw it dash, okay, if we have a less than or a greater than. So solid means that we're going to be using one of these symbols. Dashed means that we're going to be using one of these symbols. Okay. So when we draw the line, okay, it's either going to be solid or dashed. Then what we're going to do is we're going to choose a test point from one of the half planes. We do not want to choose a point that's on the line, and we want to substitute those coordinates of the test point into the inequality. Okay, when we say half planes here, ultimately if we were to graph a line, okay, on the xy axes, say we had this line right here, the half planes are going to be either this side or this side. Okay, so when we draw a line, it's going to cut the coordinate plane into halves, this side, whatever it may look like. And bottom line, we want to pick a point, and I would generally suggest that you pick the origin as your test point. The only reason that you could not pick the origin is if the line went through the origin, then you'd have to pick something else. Okay? And ultimately, if a true statement results, then we're going to shade the half plane that contains the test point, and if a false statement results, then we're going to shade the half plane that does not contain the test point. Okay? So let's see how that works. We got 3x minus 5y greater than or equal to 15. And so we need to graph that line. Notice that we replaced the inequality sign with an equal sign, and we want to graph this line. So we'll find the x and y intercepts since it's standard form. And if we do that, we can go ahead and graph those 2 points. We're going to draw the line because it's an or equal to. We're going to draw the line solid. Okay, so we did that exactly. And then we're going to use a test point, and I said I would use 0, 0. They did the same thing. You can use any point you want to, but if you can use 0, 0, it's going to be easier to test. Because if you put a 0 in for x and y, we're going to have 0 on the left, and we get 0 is greater than or equal to 15, which we know is not true. So that means we're not going to shade the side that has 0, 0 on it. We're going to shade the other side. Okay. So our final graph is going to look like this. It's going to have a line that's drawn solid because of the or equal to, and it's going to have this side of the graph shaded. And this is the answer to our question. Okay. The graph is the answer. And ultimately what we're saying is that anywhere on this line, because it's solid, okay, or anywhere in the shaded region, if I were to pick any point that lies in the shaded region, it's going to make that inequality true. Okay. Now, let's take a look at this one. Another one here, we got y equals negative 2/3 x. This one's in slope-intercept form, so we're going to graph negative 2/3 x plus 0. So we have a 0, 0 y-intercept. We have a down 2 over 3 slope. Okay. Draw it dashed because it's not or equal to. Okay, and then the test point they used here was 1, 1. Okay, can't use 0, 0 because of the fact that 0, 0 is on the line. So if we use 1, 1, we would have 1 is greater than negative 2/3, which is true, And notice where the shading is, they shaded the side that had the test point on it because the test point gave a true sentence. So again, this dashed line in the shading is the answer to this question. And once again, that means that any point that's in the shaded region, okay, is going to make this sentence true. Now, in this case, any point that's on the line is going to make this sentence false, and hence that's why it's dashed. Okay. All right. So let's take a look at vertical and horizontal lines here. Special lines that we have. We know vertical lines are always of the form x equals a. So if we have x greater than a, we're going to always shade the plane that's to the right. Okay, the half plane that's to the right of the number in question. If it's less than, we're going to shade the other side, the left side. Same with horizontal. If it's y greater than, we're going to shade above. If it's y less than, we're going to shade below. Okay. All right. So without using test points, let's see if we can do that and apply that. We have y equals less than or equal to -3. So if we graph that, got a solid line because of the or equal to, and it's less than, so we're going to graph below. Okay. Don't need a test point. It's less than, we go below. Same thing here. Dash line because of the non or equal to at x equals 2. Okay, we're going to shade to the right because it's greater than. Once again, you do not need a test point because of the fact that we have vertical and horizontal lines. Okay. All right. Now, we can also extend this to systems, kind of like what we talked about in the last section. Okay, just like we have two or more linear equations that make up a system of linear equations, we can have a system of linear inequalities. Okay, and a solution to that system is going to be the ordered pairs that satisfy both inequalities. So let's take a look at an example. Okay. The system that we're going to have here is this. We're basically going to just do exactly what we did in the previous part, but we're going to ultimately have two graphs on the same coordinate plane. We're going to graph both of these as if they were lines. We're going to have a dashed and a solid. Okay, we're going to have two sets of shading. Okay, and when we get done with all that, okay, we're going to wind up with a situation like this. We're going to shade above this one because of the test point. Okay, we're going to shade on this side of the dash line. Okay, and ultimately what we're after here is the double shaded part. The part that's double shaded, okay, is the answer. Okay, so what we're looking for is the double shaded part. Okay, that is going to be the solution to our system. Now, for our purposes, all we really need to have for our answer here when we graph a system of linear inequalities is to have both lines graphed correctly, okay, and then have them both shaded correctly. And again, the double shaded part is going to be the answer. Okay, you don't have to erase the shading and show just the part. I'll know that you got the right answer because of the part that is correctly double shaded. Okay.